So there's a bunch of examples that are sort of increasing complexity, shall we say, to drive a servo. The first one is simply a single servo that reacts to the press of a button. It's going to move into full position.
How's that? Good?
It's just this tiny little lettering up here.
I'm sorry.
It's okay.
What I can do,
You can sort of see it up here. The link, if you want to go to this on your laptop, is keyhelp.com. Real 2/real2. You can also do it on your phone, and it will work on your phone as well. Or iPad or so if you scroll down here to the playground, it's a simple servo example. And this example is going to show how to create and move a single servo when a button is pressed. So if you click on that, it'll load up here. We'll use a mega. Susan. Relocate the servos into the closure to see the pin out. So basically, in this, we're required to connect ground and power, just like in the real world, but of course, this is an infinite number of current that's going to come through here. So you connect the ground to the ground on the Arduino, and you connect the power line to 5 volts in the servo, and then you connect the signal to one of the pins. Now, a lot of the pins are capable of driving the servo, but not all of them are. For example, the pins down here do not drive the servo. A lot of these pins on the mega will drive the servo. Maybe you can increase the font size a little bit. So is this readable? Mm-hmm. All right. So this is using the Real2 library. You can, of course, use any servo library. The nice thing with this library is it moves the servos to a little bit higher level. But I will go through what loop means. In the top level, we have to include the parts of the library that we're using. We're going to use push button in the servo dispatcher for direct connections. So when you're connecting directly to the mega or the direct one, there's also the servo controller if you're using servo controller or access. You would simply include just a header file, and the rest of the code would be all the same. We're going to, for our own sake, we're going to give a name to this pin. We're going to have a push button down here. So push button just has 2 pins there. There's mirror. This is basically connected to this pin, and this pin is connected to this pin. So it doesn't matter which side you wire. But we're going to wire one pin to an input pin and the other one to ground. So this is the ground pin. So when we press this button, this pin A0 is connected to ground. So it's on pin A0. We're just going to call it next button pin for our own convenience. The next step we do is we're going to define the servo settings of all our servos. So we have more servos, which simply just do more of these lines here. So what this means is that this is the pin number the servo is on. This is the minimum pulse value that you want to send, and this is the maximum pulse value that you want to send. And this is called a group number. We're going to get into that later. This is 0 for now. And for our own sort of convenience, also we can add a comment that says, this is servo 0, and it's called my servo, or it might be, dome servo, whatever. We have to create this servo dispatcher. We'll get this. This will automatically calculate the size of this array, so we don't have to remember how many servos we have in there. And we just have a pass in the servo settings to this variable we call servo dispatcher. Right. This is just sort of set up. You can usually just copy and paste this so that like you don't. Most things you have to deal with is adding things into the servo settings. We'll create a push button and assign it to this next button thing. And this will automatically read the push button for us and we'll bounce it also so it's not going to make stray readings. So this is just a standard setup point for the Realty library. We'll attach this function open servo to this push button. So attach click to the servo, to the push button. And this is the function we're going to execute when you press this button. The loop is just empty. It's we can add code to the loop, but as long as we just have to call this animated event process so that it will do its thing. So maybe I can zoom out here now. So now if I just say run simulation, servo is set to the midpoint by the simulator, and I press the button, and you see that it bounced back there, and that's because we set this as the initial value of the servo. It's 800, so it bounced up first, and then it went to the destination. And how we move the servo is the servo dispatch move to, so you say move servo number 0 to 100% position. So we don't have to, at each location, put the pulse value we want, we can just put percentages. So that allows us to change these later if we want. We can also reverse them, what is 0% mean and what does 100% mean? We flip around the settings. So we're moving it with a duration of 2,000 milliseconds or 2 seconds to the 100% position as written as column. So it goes from 0 to 1, where you add the fractions and percentages. Any questions on this example? Is there anything clear? Yeah?
How does the servo know its location? You said it bounced back to 800, but how does it know where it is?
So inside each servo is a small potentiometer that translates this pulse value in your position, right? So it's because this initial value here is 800. It's going to move. We can change the value. We can move it to 1500. And we can run the simulation again. Compiles it, and now you'll see it didn't bounce back. Right? You can also reverse it. You can say this is 22, and this is 800, and now you see it's going to bounce into the other direction, and then go up. Does that make sense?
So behind the scenes, the reason it's doing the math is because you're not deriving any PW input
That's correct. There's no initial setting. So usually, at least in this real library, this first position is considered a closed position for dome panels. So that should be your neutral point, like where you want it to be. And then when you want to open it, you drive it to this side. And you close it again, you drive it to this side. That's the design. Let me go back. We can go to the next example. So here's basically the same example, except we're gonna automatically call close servo after 1 second. And when we call open servo, we're going to call close servo after 5 seconds. So it's the same. We have one button, we have the servo. All this other stuff here is the same, except we added these sort of initial behavior. In setup, we close the servo after 1 second, and once you press the button, it will open and then it will close again. So you can see it's now in a closed position. You press the button, opens, and the simulator freezes. No, it will stay in motion. So the simulator isn't 100% accurate. Sometimes it will generate the servos because it's trying to emulate. But otherwise, this example is the same. So this delay call feature is just so that you don't have to call delay. You just time things based on I want this to happen at this time. And you can change them inside, like as we do here. Probably we didn't do that in here, but this closed servo could send another delay call, so something is just happening periodically.
So the processor keeps cycling as a call is received.
Right. So in the loop function, you can do whatever else you want to do in the loop function. You just have to not call delay. As long as you come back and they'll call this related event process. Any questions on this example? Yeah.
So if my closed position is 800 and I open it or whatever,
Yeah.
and I close it again, what's the guarantee it's going to go to 800 at 805, 79?
Well, it's going to depend a little bit on your servo, but you know, you usually try to drive it a little bit farther than you have to, you know, and then the physical world will stop it.
Sure. It just seems like when I open and close servos,
Yeah.
after 4 or 5 times, it's never where I really wanted it.
Okay. Yeah, that is a general problem. But trying to drive it a little bit past the point that you need to be at, it might help for dome panels, for example. And also,
I find a lot of the club code gets passed around the phone is very delayed function and timing.
Right.
We have to learn to stay away from delays and then we do this, which I've never seen this.
I try to make it a little simpler so you don't have to deal with all that logic, so you can have like scheduling things. You know, we'll get into more of that stuff. Are you guys ready to move on to the next example?
I have a quick question.
Yeah.
I'm new to all this. What kind of server do you use? Or models do you have better work experience with?
Well, it's in the case of servers, usually the more money you spend on them, the better they are, but at the same time, they will burn out eventually. And so for the dome panels, I just use the cheaper servos and just replace them when they burn out. I actually run all my servos at 6 volts instead of 5 volts. They're snappier, but as long as, you know, which means they will burn out quicker, but they still last for years. But if there's something blocking them, they will burn out much faster.
Well, you're getting 6 volts coming out of the Arduino?
I have a separate regulator. So this power input here doesn't have to be, it shouldn't actually come off the Arduino in the real world. It should come off the regulator. The Arduino can't supply enough power to a servo, especially if it stalls, like there's something you're going to just reboot your Arduino. So this is a simulator, so we have infinite power here, just to keep it simple. So this, you guys agree with this example? So in the next example, we're going to have a simple servo that goes back and forth with 2 buttons. So it's basically all the same. We have a close button pin at A0 and an open button pin on A1. Our servo is the same, except we have 2 push buttons now. This is a closed one and this is an open one. We nice to listen to their like labels. So we have to attach a click. Close button is attached to close servo, and open button is attached to open servo. And then this function here, open servo. And here we're going to move servo 0 to 100% over 2 seconds. 2 seconds. And close servo is going to move servo 0 to 0% over 2 seconds. But it's pretty much the same as the other code, except we have this function. So now if we say flag, let's see. Guessing this is open. It's connected to. So the initial bounce back there, but you can enjoy it. Now if I close it, it goes back. And you can change the number of seconds you want to do. You want to move the servo close to slower, say this 4 seconds. So we'll bounce back, and then as we get close, you see it go much slower. Or we can make it go faster. Just reduce it to 200 milliseconds. There's of course an upper limit of how fast the servo can go, in which case it just ignores the value that you're using. But you don't want to go too low because it will. So here we go. Any questions on this example? Yeah, so it's the duration of the movement, right? So internally it's basically calling a function in this animated event here where it's keeping track of what the current pulse value is being sent to the servo, and it's going to scale that value over time. So it's scaling the value from 800 to 2200 over a time of 4 seconds, the use of 4 seconds. So progressively increasing the pulse value being sent to the servo. Of course, the servo can only respond in a certain amount of time, and this depends on the price of your servo, how fast it can move to a full sweep. But you can just rely on 200 milliseconds usually. Okay, value to say this, going from this to this.
I have to look at them too.
It's not accurate.
It's been 3 years that they've been building my doors, and I thought it was a percentage of the fastest speed they could open and the slowest. And I had like super fast, normal, slow, and then calm.
So there are different servo libraries out there, and some of them have like this. Yeah. So here we do it's time and so we'll get into the reason for that is the servo easing code is going to work in time. Right? So that if you want to look up bounce and the panel opens up, or the drum card too, the panel all over the place. Any more questions on this example, or do you guys want to move on to the next one? Next? Okay. So in the next example, we're going to do easing. So we're going to do exactly the same way we did before, open and close. You see this close button, open servo, move the command, 2 seconds, 0, 2 seconds. The only thing we're doing different now is we're going to call this function here, say, set easing method. And in this case, we're just setting the easing method for all the servos. So we're going to set it bounce. So we can just play, and you see it's bouncing. It's like a flap goes up and down. And there's like 20 different easing methods, both for in and out, in the starting position. You have an elastic where it's a rubber band, and there's usually you want more like a cubic or a circular where it's moving. So the servo starts slow and then moves faster and then slows down again. But it's all preference of what you want in your animation. I mean, the dark servo stuff is just doing this stuff in whatever it is. So it's all the same. Just skip ahead here a little bit. Now here we're going to have multiple servos. So the rest of the code is all the same. We now have 8 servos. We added them here. You can see we connect the bus. We pretend we have a bus bar here where we don't want to wire it this way. The voltage on the last servo will be quite a bit less. But we connected to all the pins here from A from pin 2 to pin 9. The order is important. You could plug it in reverse order if you don't want, but so you would have to just put in the pin number. It doesn't have to be sequential or anything like that. So if it's convenient for your wiring to do it, put one on pin 21 and the other one on pin 7, that's perfectly fine. So we still have the easy method of the bounce as we had before. It's all the same, except now we're going to use this new thing here, which is a servo group. So we make up a servo group and we use this binary number here, pin 1, binary number 1. So we're only going to use one servo group for all the servos. So we assign each servo here a group name. You can whatever you want. And you could have multiple groups, but we're going to start with one. Same thing again, attach click, set using, but now we call move servos, and we say the group number. This is just a big servo group is what's called a bit mask. We'll get into that in a minute, but right now this is just group 1. So if we play this, we can now press the button here. Just all the servos. And again, it will bounce. So now all the servos are doing the same thing, they're bouncing like that. The same servo I had before. Any questions on this example?
Where is the attach?
It automatically attaches. So you can manually do it, but basically after a specific number of milliseconds to specify that you have to send it a new command, and it isn't running animation, it just attaches the servo. And so here's an example with groups. So now you have two groups. You have my servos and my other servos. This is just binary number 1, and this is binary number 2. And we're going to have different easing methods for one servo. So my servos are going to have this bounce, and my other servos are going to have a circular ease out. So they'll behave differently. We're going to say move servos, my servos, and move my servos, my other servos. My servos are going to move in 2 seconds, and the other ones are going to take 4 seconds. And the close, we're just doing it in reverse. So as we play, we press here, and you now see that. Actually, there's one thing that's also different here. We reverse the direction that this servo moves in. As you see, he's going in the opposite direction, even though he's staying told the same value. So you 100% know it's the opposite direction. All you have to do is reverse the min and the max, and it'll just go in the other direction. But if you press it again, you'll see the input.
If one servo physically fails and it prevents one holding back or but everything else will work fine.
They're not interconnected. Any questions on this example? Yeah?
I wasn't sure if I would see them occurring sequentially because of how they were then, or kind of simultaneously. It looks like they're simultaneous.
In this case, they are simultaneous. So if we can show you how to do it. If you want to do it sequentially, it's the right order.
And so what's handling the PWM change?
So
that background stuff?
that's this animated event. Is doing all the calculations for the servos. But we're already on the servos today. So as long as this function is getting called, things are going to move. Any other questions on this one? The second one is the servo sequencer. Yes, this is the last example. So there's also the sequencer for there are sort of pre-programmed animations, you can also program your own. If you want to do like ants or dance and that kind of stuff, you can do that using the servo sequencer. You have to import the servo sequencer and the animation. We create two buckets, one we call ants and the other one we call flutter. We still have the same groups, except we added this other sort of meta group, which is all servos. So we can refer to the group individually, but in this case we're going to refer to all servos. Now have to set up a sequencer, we have to set up an animation player, but other than that it's the same. We create these functions marching ants, it's going to play the sequence called sequence marching ants, which is defined in here. I listed all the different sequences that are here. And we can skip besides. So, and it just which group is supposed to play on, which sequence to play, and which sequencer to use. So we have marching ants, we have flutter, we have drunk. We have open, close, open, close, long, open, close, repeat, wave, wave, fast, open, close, wave, alternating, dance, and then just back to the old loop. So in here we decided to connect the ants button to marching ants and flutter to flutter. So if we say play, we can start here with that's the flutter. See just go up and down and then closes again. And then the marching ants where it's just alternating. You need to change this here, for example, to drunk. See what that would look like. So this is a slight variation where we're going to use variable speed. We're going to use a minimum delay of 1 second and a maximum delay of 4 seconds. So this applies to individual servos, which just randomizes when it starts and when it's done. And you can have two different easy methods for the open animation or the close animation. They don't have to be the same. So now if we restart, try that. So like the panels are all over the place. But you see that the code is, the main player code is the same, you just code it player for sequence. And we can also change it, try some of the other ones. We can try games, for example. Button. It starts to individually dance. So there's a sequence of them. So the dance animation specifies sort of the order of the servos and the panels. But it's basically opening panels. So sort of rhythm. The wave. There's a wave long which goes back also. So, any questions on this example? So this is all I have for servo animation examples. Any questions?
Yeah, you have this code.
It's right here. You can play it on this website. It's a bedrock. You can change the code and run it.
No, but you'll use examples of
That's in my Droid.
Yeah.
Or I have both. So this code is all up here at the libraries. It's installed here in the library manager. With NeoPixels and the real tool installed here.
You got that page that has the links to
Yeah.
all of these real things are in.
It's all on this page.
Okay, at least,
There's quite about that picture.
Yeah, just click the picture here. There's some other, like the holo projectors, if you want to try the holo projector.
You wrote these, is what I'm saying, I mean.
This is for the real to library.
Yes.
I didn't wrote.
Okay, no, what I'm asking is like, it's a church-centered phone.
So the real to library was my attempt at making are two components.
You wrote.
I wrote, but it's also using sketches from other builders, but they've been turned into components. So instead of having a sketch that's a holo projector, now I just have this HoloLights class and just use a phone number.
I heard of this, it's really cool.
That was, so if you want to have do that, 10 12 holo projectors, you can all grab it from the same.
I've seen some people here with a lot of Nancy on the road, and Nancy on the log. So if you have the Nancy approach, Nancy on something like saying a lot of it's part of
You can make your own sequences. I can show you the sequence of code if you want to. Here, servo sequencing. This is going to be off of the region. It's basically the binary array, bit array. You have open, close. So these are all the groups. So this is basically all the servos. You have 32 groups, servo groups. You don't break into servo groups. So there could be a lot of servos in there because they're just assigned by group by group. So it's going on and off. So the sequencer only works in on and off. So this here is the second value. So for the first, for the first second, it's going to go on. No, sorry. After 1 second, it's going to move on to the next frame, which is off. Right? So it starts, the position on, and then it's going to go off. So that's the gist of it. So like the flutter here adds these extra things. You can set the range limit of the movement. Or it's not the full range, it's like half the range. So it's just on and off, we need just from this range to this range. So this is all easier with the dark servo stuff, but it's basically the same thing. You can create animations. The wave here is basically going, starts both closed, and then it opens one, and opens two, it moves through here.
So you mentioned six volts, what kind of power step down are you using for that?
I'm just using one of Christian's regulator for 6 volts. So I bring 12 volts up into the building. So I have 5 volts and a 6 volts.
I didn't know it was 6 volts.
You can ask it whatever voltage you want. Because it's just a value. It's not adjustable. So the library's up here. If you guys want to play with it, it's fun to play with simulator. You don't have to use a library, you can just use a simulator. You don't need to use any of the pixels or anything. They have a bunch of libraries on there. They also have other servo libraries. But it might just be useful to do. You don't have to move to this value and say delay 3 seconds and then move to that value. You can just make yeah.
Not really servo related, but lately I plug in my Arduino, through the USB to the computer.
Yeah.
And every time I try to upload, it says it can't find the code. I unplug it, plug it differently, still can't find the code.
Okay.
Sometimes even rebooting the PC, I still don't get it.
Okay. It could be an issue on the PC side. I mean, the FTPI upload mechanism with a little capacitor that's the drain isn't like super reliable. You know, the capacitor sometimes goes bad and then it can't reset the board. But if you can't find the board, the possibility that or the board is bad, the cable is bad, or there's some vibration. Those are the things that are. The first easiest one is to, if you have another Arduino, just try it with Arduino. If that one works fine, then your Arduino may be bad. You may, sometimes you can rewind that by reflashing the bootloader, but you need to use a different program like that using.
Suppose we could do it on the URL for GitHub, and make it out.
Oh, it's just real.
Okay.
It's an under on
Okay. And then there's, I mean, you can, as reference, you want the sketches for all my Droid arms here, Arduino. You'll have the body firmware, the dome button firmware, which isn't really too much, but dome firmware, and it's all reproducing that same code. So it's just a little sketch here. Find all the pins that we use here in the front. The technical term. So the servo settings are over here. There's a bunch of servos, this is a bunch of panels, and the ranges are defined.
We got just feedback for URLs.
Yeah, I mean, I have feedback servos in there. I don't use them where it's to read the position of the servo. But that would be a great idea first, so that the kids can move the servo up and down, and then he says that's terrible idea. So I would use that. This one is using, instead of using a servo dispatch, it's using the servo PCA. Instead of the servo dispatch direct, it's using the 9685. So it's all the same. But now you're using I2C to drive the servo controller. And this will automatically drive, this drives two servo controllers simply because I have more than 16 servos in the structure. I don't have to do anything else other than just having more servos. So these here, 15, 16, 17, 18, they're on a separate servo controller.
So you're using the PCA 0 standard?
And this is the data for I2C, the PCA 9685. But yeah, this part is not so interesting. These are the messages passed from the stuff. But yeah, you have the setup. So you set up the servo using layer and the front hollow projector, and we close all panels as a setup. So whatever state it's in, just plug. So this is the same as we were doing before when we do the sequence, the drum sequence or whatever sequence. But yeah, it's all here. If you just want to peruse, it's in the real time, you know. Interesting. Questions?
If you're in the middle of an animation, my presumption is that the commands that send to the animator, hey, do the thing, kind of overwrite the thing that was there. And we're like, so cut it short and then do the next thing.
Yeah, it will switch to your new sequence. You can run two, but usually you want this one. Because you usually want that. And if there's a running sequence, you want it to cancel the animation. There is also this animation point in there, or multi-step animations, where you're also sending serial commands and all that stuff. It's just like a little wrapper. You can see if you're interested, it's in this firmware here. You have Arduino sequence here. We have two types of things. We have Arduino action, which is it's just a function. It looks a little different, but it's basically it will map to this command. If we send this serial command, it's going to run the screen sequence, and the screen sequence is just these steps. You know, sends it to the logic engine, sends the screen sound to the sound module, and plays the open close circle sequence. There's also this animation step here, working animation, which is basically just a function that gets called repeatedly. It will come in and it will do start. It will send this much email command here, which is the Cantina song. And then there's a comment that says wait for 1 second, but apparently we don't wait for 1 second. We just go on and fire the logic. I would be weary of comments. Be accurate.
No,
We set the
see if anybody has a
logic to the
USB.
fire animation. We play a hollow short circuit sequence. We start the launching end sequence, and we wait for 15 seconds before executing the next step, which is
Yeah, right up there.
reset everything back up. But if at some point during this,
I think my
decide to execute a
that,
different
yeah.
sequence, if we call
I
it
just wanna
a
go
reset
through
step, and then start.
This is gonna be images and stuff like that.
Alright,
So I'm just gonna have my son scroll through a long time.
So the
Cool.
thing
Alright,
about
yeah, once he's done.
steps, it's
Word 3.
after executing this command here, do command here, it's gonna leave this function. It's gonna come back, and it's gonna execute the next step. So internally, this is turning into a function that's where the individual steps. So this was just an intent to make it, make a little scripting language inside. That would be this, you could say do wait seconds, 15 seconds. It won't stop the process, everything else is going to be running. It's just not going to run this next step here, where you can see there's another step that has a wait. Yeah, for example, here's the short circuit sequence, there's the logic engine alarm sequence, play screen, and wait 500 milliseconds. So this since it's going to be done command, this command won't return to this command until after 500 milliseconds.
So often what it loops will compare to an internal counter of like 100 milliseconds of pass. And so rather than block, just sit there, it'll check it.
Yeah, it'll go and do some other stuff and come back.
Well, the thing about it, some of these stuff, the individual response, like,
Yeah.
something like, that's fine, and once they get their instructions, it's when you do stuff on the sampling, you know, last and last, is where I see that,
Right, so it's going to return. So it's just gonna not come back to this part, this next step here, until after 500 milliseconds have passed. It's gonna go and do whatever else wants to do, like home serve, or lights, and then it's gonna come back and it's gonna execute the next step. So it's not actually blocking the server, it's just saying after this time we're gonna and then down here, it waits for 3 seconds, it turns on the smoke unit and waits for 3 seconds, and then it turns the smoke unit off. And, yeah, it's up there. Any more questions?
Good job.
So have you got there, so this is the URL?
You're on,